I started my career in coatings 10 years back in 2013 in a mid-sized company in the Black Forest. And back then I had a really hard time calculating mixing ratios for polyurethane resins or epoxy resins. But I think after 10 years now, I really figured that out, and what I had to do is forget about epoxy number, hydroxy number, and every formula there is, and only understand the equivalent weight and what it means. And I think you can do that too, so let's get to it. For the polyurethane system, you have the base component and you have the hardener, and you want to mix them in the right mixing ratio to make sure to get the best properties. But what is the right mixing ratio? Let's have a look on the molecular structure of these molecules. The base component of a polyurethane system, it's just a polyol, a polymer with hydroxy groups. And the hardener of a polyurethane system, that's an isocyanate. And what these polymers do when you mix them, they react with their functional groups. OH and NCO, they are partners in crime, so to say. So each isocyanate group wants to react with a hydroxy group. And what you do with the mixing ratio is you want to make sure that there is the same number of hydroxy groups as there is isocyanate groups. So what you need to do is to count the hydroxy group in your molecules, and you need to count the isocyanate groups in your molecules. A common curing agent for a polyurethane system is, for example, hexamethylene diisocyanate. And this molecule has two functional groups, here and here. So this was very easy, right? You have two functional groups in this molecule. One molecule, two functional groups. The problem in practice is that you don't really work with molecules, you don't count them, but what you do is working with weight. So can we find out the weight of this molecule? Yes, of course we can. It's the molecular weight. So this molecule is made from different building blocks. You have carbon atoms as building blocks, and you know the weight of carbon atoms is 12 gram per moles. Then we have, of course, hydrogen, 1 gram per mole. We have oxygen, 16 gram per mole. And we have nitrogen, 14 gram per mole. So what you do is you count how many molecules, how many individual molecules, and then just sum up the numbers here. And you'll find out that the molecular weight of this molecule equals 168 gram per moles. So in 168 gram per mole of our substance, of our hardener, we have two functional groups, which means our equivalent weight is 161 divided by 2, which equals 84 gram per mole. So this is what the equivalent weight is. In 84 gram of our substance, we have 1 mole of functional groups. So let's make an example for the equivalent weight of our polyol molecule. It's usually a little bit more difficult to draw polyols, so I'm just do it like this. Let's assume this molecule has a molecular weight of 1600 gram per mole. We have 1, 2, 3, 4 functional groups. So the equivalent weight is 400 gram per moles for our polyol molecule. And now the only thing that you have to do when you mix 400 grams of your polyol with 84 grams of your isocyanate, then you have the right mixing ratio. Let's look at a specific example. So we have this recipe. We have the polyol with approximately 40 grams. Then we have solvents, fillers, pigments, and additives with these amounts. And the question is, how much hardener do we need? We take the numbers from earlier. So we have the polyol with an equivalent weight of 400 gram per mole and the hardener with an equivalent weight of 84 gram per mole. And as I said earlier, if you mix 400 grams with 84 grams, you're fine, you're good. Problem is now you only have 40 grams in this recipe. So how do you calculate the right amount for the hardener? So that's quite simple actually. If for 400 grams you need 84 grams, then if you only have 40 grams, you need 84 divided by 400 times 40 grams, which equals 8.4. So in this example, for this specific recipe, you need 8.4 grams of hardener. But of course, that's sometimes a little bit difficult because you don't always know how much polyol you exactly have, or sometimes you might want to have, you might want to mix, I don't know, 400 grams of paint, and the other time you only want to mix 100 grams of paint, or sometimes you want to mix 500 kilograms of paint. So that's a little bit tedious. So what you actually want to do is to have a ratio for your paint that tells you how much hardener you need to add to your final paint and not to your polyol. So that means in this example, we have a total of 100 grams here of paint. And for 100 grams of paint, we add 8.4 grams of hardener. Or maybe better for the mixing ratio is if when we say that we have these 100 grams divided by 8.4 and the 8.4 divided by 8.4, which leaves us with a mixing ratio that's of 12:1. And that means if you have 100 grams of paint, you divide that number by 12 and you know how much hardener you need to add. And if you have 500 kilograms of paint, you divide 500 kilograms by 12, and again you know how much hardener you need to add. And that's it, that's all the magic, and it's the same for all two component systems. No matter that is epoxies or polyurethane, equivalent weight is the same for all of them. If you understand that, you can do all the calculations that you need. And I really hope that it also clicked for you now, the same as it did like 6 years ago for me, that I really understand how to calculate these mixing ratios. And if you gained some value from this video, please consider subscribing to this channel, because that shows me that I should continue with these videos. And that's it. See you in the next video. Cheerio.